Okay, in 4.2, we're going to look at logarithmic functions. And so first, let's start out right here and look at this. The inverse of an exponential function is a logarithmic function. So we just got done graphing exponential functions. We graphed a bunch of them in the previous video. And so what we're going to do here is if we look at an exponential function, let's follow the steps for how you would find the inverse. So first, you would switch from function notation to using a y. Then you would swap the x and y. And then what? How do we solve for y? Because that's our next step after we interchange x and y is we solve for y. Okay? Well, as you can see over here, the question mark indicates that we do not have a method for solving for y. To isolate the exponent y, a new notation called logarithmic notation is needed. The inverse function of the exponential function with the base b is called a logarithmic function. So that's what we're going to look at here is what do we do? And I'm going to have this down below, but essentially what we do, let me just go ahead and scroll down to this. Essentially what happens here is if you have b, some base to the power of y equals x, and you're trying to solve for y, we convert it to this thing called logarithm form, to where your exponent is now on its own, so y equals, and then we have this log, and then base b of x right here, and now we have solved for y. And so now you might be thinking, okay, what does this mean? Log base b of x. What does that mean? Well, all that really means is what we have right here. These two notations are actually the same thing. It's just in a format where we can have y equals. And so you're still, what it is you're asking yourself b to the power of y equals x. And so what we're looking for here is, so if we had something like, well, let's look at this example we have up above. We have log base 2 of x right here. We have log base 2 of x. And so if you plug in different x values, so for example, if you plug in a 2, what you're asking yourself is 2 to what power would give me 2? That's what this is saying right here. The 2 is the base. The 2 is your base right there, right? That's the base. And then the y is my answer. That's what I'm looking for right there. That'll be my answer. And then the x value is what I'm plugging in right here, which is the 2. So 2 to what power gives me 2? Well, 1. And then if you were to plug in like a 4, you would have, 2 to what power would give me 4? And that answer would be a 2. So that so really logarithms, you're just solving for exponents. You're just solving for exponents. And so over here in purple is my logarithm function right here. Now you can see across my dashed line, that's the exponential function, because if you recall from inverse functions, they're a reflection of each other. The inverse is a reflection across the line y equals x, which is this dashed line right here. And so back to kind of more of a formal definition of logarithms. So for x greater than 0, so you have to, what you're evaluating has to be greater than 0 right here. Oops. And that'll be important later when we talk about domain of these. But right there, that has to be greater than 0. The base also has to be greater than 0, and it cannot be equal to 1. That kind of goes back to our exponential function definition. And so then we have y equals log base b of x is equivalent to what I was showing you earlier right here, b to the power of y equals x. And you can kind of see this right here. We kind of have this pattern. Sometimes that just helps students kind of remember where each piece goes. So base to this power equals x. So b to the power of y equals x. And so that's just a nice little way of remembering how to write that. So also you can see right here, this is the exponential inverse right here, and you can see that the x and y values get flip-flopped. So like right here, when you plug in these x values and with a base 2, you get these results. And then when you have log base 2 of x, the results are getting flip-flopped. And that's actually part of the definition of inverse functions right there. So There's going to be a lot to cover here, and at first, like I said, it can feel a little weird, but once we do quite a few examples, I think you're going to be all right, but it does take a little bit of time. We are going to graph eventually, but that's not where we're going to start, though. Really, we kind of want to just start with making sure we understand how to change from logarithmic to exponential form. So we're going to take this format and convert it into exponential form because sometimes we have to kind of go back and forth depending on the situation that we're trying to solve. So right here, this is going to be 2 to the power of 4 equals 16, which we know is true, but really right now we're not really solving, we're just practicing the conversion. So then this would be 3 to the power of negative 2 equals 1/9, which once again, that is true, right? And then here we flip the order on you a little bit, just trying to kind of throw you off a little bit. We put the log on the left side, but it works the same way. It's going to be 16 to this power equals 4. So 16 to the 1/2 power equals 4, which is true also, and we will review this. But right here, raising to the half power is the same thing as square rooting. And you can see that the square root of 16 does equal 4. But like I said, right now we're just kind of practicing converting back and forth. And so now we're going to go the other direction. Now we give it to you in exponential form, and we want you to convert it back to log form. So the base right here, so you're going to have log base 2 of 8 is going to be equal to 3. So we're going to have log base 2 of 8 equals 3. Because what's going on here, eventually we're not going to give you all 3 pieces. Eventually you're going to be missing one of the pieces. But really all this is saying is 2 to the power of 3 equals the value right here inside the parentheses. So same thing here. Let's see, we're going to have log base 2 of 1/16 is equal to -4, because if you take 2 and raise it to the power of 1/4, you'd have to reciprocate it, and then it would turn into 1/16. And then let's see, we got one more here. So we've got log base 10. So log base 10 of 0.001 is equal to -3. And that's all you're writing. That's correct. Because if you take 10 and raise it to the power of -3, causes it to flip. And then 10 times 10 times 10 is 1,000. And 1 over 1,000 is the same thing as 0.001. But like I said, right now, we're not even solving yet, but that's what we're going to do in a moment on the next slide. But this was more of just kind of an introduction, so it can feel a little overwhelming, especially if you've never seen these before, and especially with the graph up here. So don't worry too much about the graph right now. We're definitely going to talk about that, but that's actually at the very end. We're still going to kind of start introducing exactly what a log function is on the next slide and on the next video.